So as we go on our search here for different types of reactions, the last VodCast actually is needed for this particular reaction, because we are now going to do what are called double replacement reactions. But in order to fully understand double replacement reactions, we needed to deal with that solubility issue, because what's going to happen now are we are going to get substances that are soluble and substances that are not soluble. Okay? So, in a double replacement reaction, first of all, we'll define it. Okay? It's our fourth type of reaction. So, if you recall, I said there's 5 types. We have basically one more type to go through after this. In a double replacement reaction, which is sometimes called a displacement reaction, okay, just like a single displacement, what you have are 2 different things that are going to replace. Okay, so here's our generic equation that we had, and what's going to happen now is, unlike a single, or kind of like a single replacement reaction, A went over and it's going to replace B, but in this reaction, B then is going to say, okay, if you're going to kick me out, I'm going to go and replace you. Okay, so our products then are AY and BX. So it's kind of like a single replacement reaction, but now the substance being replaced has someplace to go. Okay, so in this reaction, they are often called precipitate reactions, because what happens is 2 soluble reactants often produce a precipitate. So you're going to see a lot of precipitates now. Okay, now a precipitate, remember, is an insoluble product that's going to be formed. It's going to be a solid that actually falls out of a solution. So as I just mentioned, a lot of times these are called precipitation reactions. Okay? So again, what I want you to do is, after you're done watching this VodCast, come up to me and I'm going to show you a demo on this. Okay, so I want you to see a demo. Okay, so we'll just actually get into some different types of precipitation reactions then. Okay, so here I have copper sulfate, which you'll notice is aqueous, or dissolved in water, and I have sodium hydroxide, which is aqueous or dissolved in water. So you have these 2 things that are dissolved in water. So water is just the medium that is going to allow the reaction to occur. And in this double replacement reaction, copper will go ahead and kick out sodium. So this copper is going to react with the hydroxide. Now, you do have to pay attention to charge. This copper is a +2 charge. Hydroxide is a -1 charge. So my product is going to be CuOH2. Okay, so that's my first product. And then my second product, the sodium, says, okay, copper, you're going to kick me out. I am going to produce, or I'm going to react with the sulfate, but remember, sulfate is a -2 charge, sodium is a +1, so I'm going to get Na2SO4. Okay? And so that's your double replacement reaction. 2 things replace each other. Now, the other part of this double replacement reaction is looking at these 2 products. As I look at those 2 products, one is going to be insoluble and one will be soluble. So now you go to your solubility chart. Okay? And we're going to figure out which one's going to be soluble and which one's going to be insoluble. And if you remember, the one rule I told you to memorize was that all group 1 elements are always soluble. And this is where memorizing that really pays off. Because here I have a group 1 element, okay, and that's always soluble. So I know that this is going to be aqueous, okay, and then copper hydroxide is going to be solid. So you're going to have to add those subscripts in. okay, because they're going to tell you what the reaction is doing. Okay, so we're just going to look at a bunch of examples here. And I might not have enough room, so I may be writing my products. In fact, I am going to write my products down here just to make more room. So, double replacement reaction, calcium kicks out the sodium. So the calcium is going to react with the carbonate, and I'm going to get CaCO3. Okay? That's my first product. My second product, sodium replaces the calcium, and I'm going to get NaNO3. Okay, so those are my two products. Okay, now I didn't do this on the last one, but we should always balance. Okay, we need to balance these. So in order to balance these, I have one calcium and one calcium, so that's balanced. I have one carbonate, so that's balanced. I have two NO3s, and I have two sodiums, so I need to put a 2 in front of there. Okay? I didn't do that on the last one, but we should always balance. Then, which one's going to be solid and which one's going to be aqueous? This is a group 1 element. Group 1 elements are aqueous, calcium carbonate, solid. Okay? So double replacement reactions are actually some of the easiest types, and by now writing formulas should be old hat. We should not have any problems with writing formulas. Okay, see a little mistake here I'm going to fix. Okay, so products here. Lead replaces sodium, so I get PbI2. Okay, sodium replaces lead, NO3. Those are my two products. Okay, I should balance. So balancing, I put a 2 there. That should take care of it. Okay, so that's balanced. Then, okay, go over here. Of those two, which one's aqueous? Which one is a solid? And you should be looking on your solubility chart. This one's aqueous. That one is solid. Okay, one last one. Write the products. And your product should be ZNS plus NaNO3. Okay, and then fill in which one's aqueous, which one is solid. And I kind of have NO3 on all of these kind of by accident. So NaNO3 is the solid, or NaNO3 is the aqueous, ZNS is the solid. Okay, so that's double replacement reactions, but you're not done. Okay, now in double replacement reactions, one of the things that happens is you have what are called ionic and net ionic equations. Okay? Now, I'm going to take the last equation that we did. Okay, so we're going to work off of that. But we're going to talk about ionic and net ionic equations. So that should be the title of this little section. You should just title this ionic and net ionic equations. Here's what happens. Okay? With this big equation where these things are aqueous, and I forgot to bring those parts over, and these are solid, that's aqueous. We can write what's called an ionic equation. And what an ionic equation does is it shows all reactants and products that are soluble as ions. So it's actually going to be a big, long equation. And what we do is we break apart all the substances that are aqueous. Okay, we break everything apart that is actually aqueous. So, going back up to our equation, this ZnNO3 is aqueous. So we're going to break it apart into its ions to write the ionic equation. So it would be Zn, and when I write an ionic equation, I have to put in the charge. Zn plus 2NO3 minus. So it's a lot like the solubility equations that we just wrote, except we're not writing every little thing out. Okay? And then that is plus this substance, okay, which is Na plus plus S, and we have 2 minus, but I have 2 Na pluses there. Okay? Now, that is the first half of our ionic equation. And then that's going to yield, okay, ZnS, which is a solid, and because that's a solid, we do not break that apart. It's not aqueous. Okay, but this is aqueous, so we add 2 Na plus ions plus 2 NO3 minus ions. Okay, so that's actually what's called an ionic equation. Everything that's soluble is broken apart into the ions. Okay? Now, we are going to show what's called a net ionic equation. Okay? A net ionic equation only shows the ions that formed the solid or the precipitate. Okay? In other words, it only shows the ions that actually reacted. Okay? Okay? That's what this does. Okay? This ionic equation only shows the ions that actually reacted. So, as I go back up to this equation right here, so I'm looking at this equation, okay? What happens is this works just like a math equation. And remember, this right here is an equal sign. And when I have the same thing on both sides of an equal sign, I can get rid of them. So right here, I have 2 NAs, and over here, I have 2 NAs, so I can get rid of those. And right here, I have 2 NO3 minuses, and over here, I have 2 NO3 minuses, so I can get rid of those. Now, this right here is a solid, okay, and these are ions, so I can't get rid of those. So what I have left then is my net ionic equation. So what I have left is what I write down. So when I write down Zn 2 plus S2 minus yields ZnS solid. And that is my net ionic equation. So this right here is called the net ionic equation. Because it shows what is left over. Okay, now I have one more definition to give you here, and that definition is called spectator ions. Now, what do spectators do? Okay, well, spectators at sports events just watch. They don't participate in the actual event. Well, spectator ions are the exact same thing. Okay, what spectator ions are ions that do not react. So they're spectators. In other words, the ones that we crossed out. The ones that we crossed out are the spectator ions. Okay, so let's look at another reaction. Let's take this reaction, and first of all, I want you to write the products. So the products of this reaction, okay, would be Na to barium, and that gives me NaCl. And then the barium replaces the Na, and I get BaSO4. Okay, so those are my two products. Now, on my two products, I want you to pick out which is the aqueous and which is the precipitate, or the solid. And at this point, group 1 element with sodium, so that is the aqueous. Barium sulfate is the solid. Okay, now we're going to take this and we're going to write out the ionic equation. Okay, now the ionic equation takes everything that is aqueous, okay, and everything that's aqueous is this, this, and that, and it writes those as ions. Okay, so we'll start here. And we'll break that apart into its ions. Its ions are 2 Na plus ions plus SO4 2 minus ions. Okay. Then we'll break this one apart. It breaks apart right there. Plus Ba 2 plus ions plus 2 Cl minus ions. And that's going to yield, okay. Oh, I just should have balanced this. I'm sorry. I needed 2 there. Okay. Needed to balance this. And that's going to give me 2 Na plus ions plus 2 Cl minus ions. Okay. And then this does not get broke apart. So it's plus, and my plus should be up here, but plus BaSO4, which is still a solid. Okay? So that's my ionic. Now let's write the net ionic equation. The net ionic equation crosses out all spectator ions. So 2Na and 2Na are spectator ions, so they cross out. Cl and Cl are spectator ions, so they cross out. So what I have left are the Ba2 plus ions plus the SO4 2 minus ions, and those produced BaSO4 solid. Okay, now one thing here, notice I changed the order of those two, because you should always write positive ions first. Now, I'll be honest, at this point, I'm just going to run through a couple of examples. So if you have this figured out, you should go ahead and work on the worksheet. If you don't, you should continue watching, because I'm going to break this apart even more to help people that aren't quite getting this yet. Okay? So, go ahead and write down this reaction, KCl plus Na2CO3. And go ahead and write the products. And the products are K2CO3 plus NaCl. Now, with this particular reaction, these are two products, and so find out which one is aqueous. And what you'll be finding is that both of these are aqueous. And when both of those are aqueous, this is a no reaction. Because you would not get a precipitate on this particular reaction, because everything is aqueous, you have a no reaction. And when you have a no reaction, there is no need to write ionic or net ionic equations. Okay, no need to write those. Let's look at another example. Okay, this will not be a no reaction, and I am going to break this one down really far as what you actually need to do. Okay, forgot the aqueous here, I see. So, write the products of this reaction. And the products of this reaction are NiOH2 plus NaNO3. And we need to balance this. Okay, so in order to balance this, I'm going to need a 2 here and a 2 there. Okay, so now I'm balanced. Now, on your two products, pick out which one is aqueous and which one is the solid, and you will have a reaction here. And there's that silly NaNO3, which we've been using all day. So that's going to be aqueous. That's your solid. Okay? So now, what we want to do is we want to write out the ionic equation. Okay, now I'm going to do something that I haven't done in the past, okay, just to show this. But I need to take this and I need to break it apart and I need to write it down. So this would be NiNO3, 2. Okay, and if we broke this down, this breaks down into Ni2 plus 2NO3 minus. Okay, but when I write this ionic equation, this is actually all I need to write. So I'm just kind of going back here a little bit to the last solubility chapter that we did. And this is all I'm doing is I'm taking this compound and breaking it into those ions, but we're just doing it all in our heads. So I write Ni2 plus 2NO3 minus. Okay, and then I'm going to take this and I'm going to do the exact same thing. Okay, but we're doing it in our head. So 2Na plus 2OH minus. That's going to yield NiOH2, which is a solid, plus 2Na plus 2NO3 minus. So that's my ionic equation. Now let's write the net ionic. Now, again, the net ionic cancels out everything on both sides. There's 2NAs, those go away. 2NO3s, those go away. So with the net ionic, I write down everything I have left, which is Ni2 plus 2OH minus yields NiOH2 solid. Okay? So that's what you do with double replacement reactions. Okay? And I don't have any more examples. You should now be able to complete the double replacement reaction worksheet.